G'day, I'm Glenn Morris from the Smart Energy Lab, and I'm here at All Energy, the amazing All Energy after 3 years of waiting. And I'm here with Paul Wilson. Now, Paul and I have known each other for 12, 13, 14 years.
I think so, yep.
Yeah, you've probably seen some of the videos we've made together. I'll link them up here. But Paul, I'm always excited coming to see what you're up to, and there's quite a few things. But for the audience, tell us a little bit about Arvio.
So Arvio Australia is a company based in Melbourne, in Victoria, and we design and manufacture battery systems and batteries, and we also develop software for the integration of technology. So we can bring in inverters and batteries and air conditioners and car chargers all into one place, so that you can sort of make smart decisions about how energy gets used.
So you're really a 360-degree company. It's not just hardware, it's the management of that.
Yeah, it's most important thing is that it all works properly and that it's monitored, so we can make sure it's doing what we said a long way down the track. And we've been able to prove that. Actually, we started testing and cycling a battery about almost two years and 4 months ago. We started cycling it, and we monitored it through our software platform to prove that it would do what we said before we made a big deal about it.
And is that the big deal behind you?
It is, actually. Do you want me to show you?
Yeah, show it to me.
Okay, so over here, we started cycling on the 12th of July 2020. Sorry, cycles 1 to 12, July 23rd, 2020. And we cycled the unit 12 times on that day. We thought, oh, that's pretty good. How about we cycle it some more? So we'll cycle it until it actually fails. And so we set it at about 45 degrees Celsius after that, and we ran it at 45 degrees Celsius and cycled it.
Let's go down the other end and have a look at it.
Have a look. So this is actually the real cycles right here. Cycles 13 through to cycle 11,000. Now that's, if you do the calculations, that works out to 28 years. So if you want a battery that lasts 28 years, well, we just cycled at 28 years. At 1C, which means 1 hour up, 1 hour down, which is actually quite hard on a battery normally. And this is actually every single real cycle. The little green triangles here is the days. So if you count all those green triangles, you'll actually count 11,000 cycles. So if you go over here, so you'll count, this is each day, and each cycle there's 12 per day, sorry. And right over here to the right over here, this is cycle number 11,000 to 11,013, which is 2 days ago, okay? 23rd of October 2022. And you can see here it's cycling the same way. But what's really interesting is on this chart over here, the energy that's being put into the module over the day is 23.256 kilowatt hours, and we've pulled out 21.41, which turns into a 97.5% round trip efficiency. So we lose almost nothing. It's about 1.25% per charge direction at 1C. That means a 1 hour charge, which is a lot of pressure on a battery normally. And then if you come right over here to the last day here, we're running at 23.748 in and 21.902 out, which is actually an increase of about 1%. So for some reason the battery got better after 11,000 cycles. We predicted it would flatline, but better, hey, I'll take better. So that's 2 years, 3 months, and it's still cycling right now. And we'll keep cycling it until we kill it. We think it'll take 80 cycled years.
All right.
80 simulated years, which is about maybe 7 years of cycling at 1C every hour.
Okay, wow, that battery's going to be stay put for a long time.
Yeah.
Better not move your factory again.
That's right. So a lot of battery chemistries, they can't cycle this fast, so they're going to have to project what the cycle of the light battery will do.
Yep.
This is actually real cycling, so we can confidently say it will do what we say.
Cool. Now,
yeah.
I know you've got something, I think it's sort of an alien technology.
Another alien technology? Come on, I'll show you over here.
Okay.
The battery that I showed you cycling a minute ago is a 2.2 kilowatt hour module. That's what we were building almost 3 years ago. Now we make a 2.5, but we also make a 6.2 kilowatt hour module, which is a lot larger, so for bigger projects. And they series connect on these copper bars here, so you make a higher voltage and so on. The reason I'm saying that is that lets you go up to really high voltages, so we can go up to 800 volts or 1000 volts DC using this method. Then we thought we need an inverter which can actually give us that amount of AC power. So each one of these modules can produce 60 kilowatts of power from 6.2 kilowatt hours of energy storage, so it's 10C. So
wow.
We do a 6-minute charge, 6-minute discharge. So if we series connect enough of these together, we reach the voltages that this inverter wants to see, which is up around the 900 volts to 1200 volts DC. If we do that, this little inverter here, which is only this big by this big by this big, can produce 1.5 megawatts.
So that's basically the size of a bar fridge.
It is, and it can make 1.5 megawatts.
That's what I'm saying. It must be alien technology.
It must be alien technology. now, it does need an isolation transformer as well.
Yep.
So most inverters come with the electronics and the inverter and the transformer in the same box. In this case, they're separate, so you have to add a transformer to that. So that does take up more space as well. But you can have the different proportions. So you could put say, for example, a 3 megawatt transformer with this and a 1 megawatt solution on the inverter, and then you could grow the inverter side.
And is this the combined unit here?
No, that's just a different outdoor version of this.
Right.
So you can get different models. Some of them have got PV in as well, directly. This one here is grid interactive, microgrid, grid forming, and AC coupling. So you can put Fronius on the load side, for example, or some other brand, and then we can pull that power in and charge and discharge the battery. We can interact with the grid, and if the grid fails, we can open circuit and then grid form. When the grid recovers, it can reconnect. So this here is 1 megawatt, 2 megawatt, 3 megawatt, 4 megawatt.
Wow.
In a very small package. And because we developed a software dashboard that controls and integrates with multiple brands, all we need to do is write the little bit of code that links the Modbus of this device with our software platform, and then all the battery and inverter comes through in one place.
So you're taking something that starts off as about a 45 amp hour cell,
Yes.
and building megawatt scale storage with megawatt power.
That's right. So you could take a shipping container, put in one of these, put in one transformer in the end of it, and then put in, say, maybe 400 kilowatt hours of these, and you have a 1 megawatt AC output with 300 kilowatt hours of storage, so say 20 minutes of burst energy. So you have, like, say, one of those fast chargers for the electric vehicles, the 75 kilowatt ones from Tritium, and you could bring up your car and you could have 300 kilowatt hours in the container. You could pull up your car and it'll charge as fast as the car will take it. So some of the new cars can charge in 20 minutes.
Wow.
And so as long as the inverter can make the power and the battery can deliver the power, then you can have a fast charging EV network.
Yeah.
All thanks to a very fast and powerful inverter and a very powerful battery.
This could appeal to, let's say, a shopping centre whose supply is already kind of maxed out.
Yes.
And then you want to put in a bunch of tritiums there, and
Yeah.
they go, where are we going to get another megawatt from?
Yeah, so if you have a constrained supply, let's
Yeah.
say you only had a megawatt coming into the shopping centre and you've
Yeah.
got to add on all these charges, then this will give you extra power.
Yeah.
And also it lets you buy the power and the energy when it's cheaper,
Yeah.
which matters. And then you could start playing the market. You could play FCAS and arbitrage and all kinds of things to push and pull from the grid when it makes sense economically according to the rules.
So you only need 5 of these, and you're in the...
You can have a 5 megawatt peaking plant with just 500 kilowatt hours of storage.
And then you're in the FCAS market all by yourself.
Yeah, you don't have to have much energy storage because it's so high powered.
Yeah.
So this is probably the cheapest battery per kilowatt of power. It's probably the cheapest battery per kilowatt hour life, like if you divide the cycles by the cost, but it's probably the most expensive per kilowatt hour.
Yeah.
So you pay more for a product that lasts longer and has more power. That's really what it is.
Yeah.
So it's not for everyone.
Yeah.
If you just wanted long, slow discharge, buy lead acid. If you want super high powered, long life, high cycling, reliability, high performance, this is the choice.
Right. And what do we call this product?
This is the Arvio Titan.
Yep.
And it's available in all different voltages, and you can series connect and parallel here. There's a chart on the spec sheet. So you can buy different models and different voltages. So this same model here comes in 7 different voltages.
Wow.
So we just parallel and series differently.
And you make these in Melbourne?
They're built in Melbourne, yep, and all the software is developed here in Melbourne.
Fantastic.
And the website is ucb.myarvio.com.au, and it lets you go in and add all sites and add users and add other equipment. So you could, for example, add in an Ocular EV charger, an Arvio battery, and a Daikin air conditioner on the one portal, and write rules around what you should do in the event of other things occurring.
Great.
Yeah.
Well, Paul, thanks for introducing me to the alien technology. I think that's what A in Arvio stands for.
Maybe it is. Thanks,
It's good
Glenn.
to see you
Appreciate it.
again.
Good to see you.